Welcome to our tech channel, where we delve into the world of technology and its inner workings. Stay up to date with our latest videos by hitting the notification bell and subscribe to support our channel. Let's get started. What is blockchain? Blockchain is a distributed digital ledger technology that allows data to be stored and recorded in a secure and transparent manner. Essentially, a blockchain is a digital ledger of transactions that is distributed across a network of computers or nodes. Each block in the chain contains a set of transactions, and once a block is added to the chain, it cannot be altered without consensus from the network. One of the key features of blockchain technology is its decentralized nature, which means that there is no central authority or single point of control. This makes it highly resistant to censorship and tampering, as well as ensuring that the system is more reliable and trustworthy. Another important aspect of blockchain is that it uses cryptography to secure the data, making it virtually impossible for anyone to alter or manipulate the data in any way. This makes blockchain ideal for applications where security, transparency, and immutability are important, such as in financial transactions, supply chain management, and voting systems. To understand blockchain technology, it's important to first understand the concept of a ledger is a record-keeping system that tracks financial or transactional data, such as credits, debits, and balances. In traditional accounting, ledgers were physical books that recorded financial transactions. Nowadays, ledgers can be digital, and they can track a wide variety of data, not just financial transactions. A distributed ledger is a type of ledger that is spread across multiple computers or nodes in a network. In a distributed ledger system, each node has a copy of the ledger, and changes to the ledger are validated by consensus among the nodes. This makes distributed ledgers more secure and resilient than traditional ledgers, as there is no central point of failure or control. The ledger is maintained by a network of computers, or nodes, which collectively verify and validate each new transaction. Because the ledger is distributed across the network, rather than being controlled by a central authority, it is extremely difficult to hack or manipulate. This makes blockchain technology a highly secure and transparent way to record and manage data. Distributed ledgers are used in various industries to improve transparency, reduce fraud, and increase efficiency. For example, in finance, distributed ledgers are used to facilitate cross-border payments, digitize assets, and create smart contracts. In healthcare, distributed ledgers are used to store medical records and track the supply chain of drugs. In supply chain management, distributed ledgers are used to track goods from their origin to their destination, improve transparency, and reduce fraud. Cryptographic methods. To ensure the security of the data on the blockchain, cryptographic methods are used to protect the transactions and prevent unauthorized access. Specifically, the blockchain uses hash functions, digital signatures, and public key cryptography. A hash function is a mathematical function that takes in data of any size and produces a fixed size output, usually represented as a string of characters. Hash functions are used in blockchain technology to create a unique digital fingerprint of a block of data, which can be used to verify its authenticity and ensure that it hasn't been tampered with. Hash functions are algorithms that convert data of arbitrary size into fixed-size hash values. Each block on the blockchain contains a hash value that is unique to the data it contains. Any change in the data would result in a different hash value, which would be immediately recognized by the network. Here's an example of creating a table with 5 hash keys using the SHA-256 algorithm. In this example, the message column contains the input messages that were hashed using the SHA-256 algorithm. The hash key column contains the resulting hash values, which are 256-bit numbers represented in hexadecimal format. Note that the hash keys are unique to each input message, and even small changes to the message will result in a completely different hash value. This property makes hash functions useful for verifying the integrity of data, since any changes to the data will result in a different hash value. Public key cryptography, also known as asymmetric cryptography, is a method of encrypting data that uses a pair of keys, a public key and a private key. The public key is used for encrypting data, and it can be freely distributed to anyone who wants to send encrypted messages to the owner of the public key. The private key, on the other hand, is kept secret and is only known to the owner of the key pair. The private key is used to decrypt the data that was encrypted with the public key. In blockchain technology, public key cryptography is used to secure transactions and ensure that only the intended recipient can access the data being transmitted. Each participant in the network has a unique public and private key pair, which they use to sign and verify transactions. When a transaction is initiated, it is encrypted with the recipient's public key, and it can only be decrypted by the recipient using their private key. Public key cryptography is a key part of blockchain security, as it ensures that transactions are secure and that only the intended parties can access the data being transmitted. Here's an example of creating a table with 5 hash keys using public and private key cryptography. In this example, the message column contains the input messages that were encrypted using the public key, and can only be decrypted using the corresponding private key. The public key and private key columns contain the pair of keys used for encryption and decryption. The encrypted message column contains the resulting encrypted messages. Note that the encrypted messages can only be decrypted using the corresponding private key, which is kept secret by the owner of the key pair. This property makes public and private key cryptography useful for secure communication, since only the intended recipient can access the encrypted message. Digital signatures use public key cryptography to ensure that only the sender of a transaction can sign and authenticate it. The sender uses their private key to generate a digital signature for the transaction, which can then be verified by anyone with access to their public key. When someone receives a digitally signed transaction, they can use the sender's public key to verify the signature and confirm that it was indeed signed by the sender. If the signature is invalid, it means that the transaction may have been tampered with or forged. Digital signatures are an important tool for securing digital transactions and ensuring that they can be trusted. They are used in a wide variety of applications, including online banking, e-commerce, and digital contracts. A wallet is a software program that stores private keys, which are used to access and manage cryptocurrency assets. Private keys are essentially secret codes that give the owner access to their cryptocurrency holdings, so it is essential that they are kept secure. A hot wallet and a cold wallet are two different types of cryptocurrency wallets that are used to store cryptocurrency assets. A hot wallet is a cryptocurrency wallet that is connected to the internet and is therefore considered to be more vulnerable to hacking and theft. Because hot wallets are connected to the internet, they are more convenient for making transactions and are often used for everyday trading and transfers of cryptocurrency. Examples of hot wallets include mobile wallets, desktop wallets, and web wallets. A cold wallet, on the other hand, is a cryptocurrency wallet that is not connected to the internet and is therefore considered to be more secure. Because cold wallets are not connected to the internet, they are less vulnerable to hacking and theft, making them ideal for storing large amounts of cryptocurrency assets over a longer period of time. Examples of cold wallets include hardware wallets, paper wallets, and even offline computers used exclusively for storing cryptocurrency keys. Achieving consensus. Consensus is achieved on the blockchain through a process called mining, which is carried out by nodes on the network. In order to add a new block to the chain, a node must solve a complex mathematical problem that requires significant computing power. Once the problem is solved, the node broadcasts the solution to the network, which then verifies the solution and adds the block to the chain. This process ensures that all nodes on the network agree on the state of the blockchain and the validity of the transactions recorded on it. In addition, the mining process incentivizes nodes to participate in the network and maintain the integrity of the blockchain. Consensus mechanisms are a critical component of blockchain technology. They enable nodes in a distributed network to agree on the validity of transactions, ensuring that the network remains secure and trustworthy. There are several different consensus mechanisms used in blockchain networks, each with its own strengths and weaknesses. Proof of work, POW, is a consensus mechanism that requires nodes to perform complex mathematical calculations to validate transactions and add blocks to the blockchain. The first node to solve the calculation and add the block is rewarded with newly minted cryptocurrency. Each block in a blockchain contains a set of transactions submitted to the network for verification. To validate a block, nodes must reach a consensus or agreement that the transactions in the block are valid and that the block has not been tampered with. This is achieved through a consensus mechanism that governs how nodes communicate and agree on the state of the network. The most common consensus mechanism used in blockchain networks is proof of work, which is computationally intensive and requires significant energy. Other consensus mechanisms such as proof of stake, POS, delegated proof of stake, DPS, and proof of authority, POA, use different methods to validate blocks and achieve consensus. Once a block has been validated and added to the chain, it cannot be altered or deleted, as each block contains a unique cryptographic hash that is linked to the previous block. This creates an immutable and transparent ledger that can be used to track and verify transactions without the need for a central authority or intermediary. Proof of stake, POS, is a consensus mechanism used by some blockchain networks, where validators are chosen based on the amount of cryptocurrency they hold and stake in the network. The more cryptocurrency a validator stakes, the higher the chances they have of being chosen to validate a block of transactions and earn rewards. It's a way for some computer networks, called blockchains, to make sure that people who help verify transactions are doing it honestly. Instead of using a lot of energy to solve math problems like another method called proof of work, POS chooses people to verify transactions based on how much of the network's digital money they own and stake, or put up as collateral. These people are called validators and they earn rewards for doing their job correctly. If they don't do their job honestly, they can lose their digital money. Validators in a POS network are responsible for verifying and adding transactions to the blockchain. To become a validator, one must lock up a certain amount of cryptocurrency, known as the stake. The stake serves as collateral and can be lost if a validator is found to be acting maliciously. In POS, validators are selected through a process known as coin age or coin maturity. Validators with a higher stake have a greater probability of being chosen to validate the next block in the chain. Validators are incentivized to behave honestly and protect the network, as they stand to earn transaction fees and additional cryptocurrency rewards. One advantage of POS is that it is more energy efficient compared to proof of work, POW, which requires miners to perform complex calculations to validate transactions. This is because POS validators only need to hold cryptocurrency and participate in the network, rather than perform intensive computations. However, one drawback of POS is that it can lead to centralization, as those with larger stakes have more influence over the network. Another concern is the potential for a nothing-at-stake attack, where validators have no incentive to choose the correct blockchain in a forked network, leading to a consensus failure. This issue can be mitigated through the use of penalties or other mechanisms to discourage such behavior. Validators who behave dishonestly lose their stake tokens as a penalty, known as slashing. This discourages malicious behavior and helps to maintain the integrity of the network. Overall, POS is better for the environment because it uses less energy, but it can also lead to some people having more power than others in the network. There are also concerns about attacks on the network, but there are ways to prevent this. POS has gained significant attention in recent years as a promising alternative to POW in the blockchain industry, and it will likely continue to be a topic of discussion and research in the coming years. The importance of blockchain lies in its ability to create trust, security, and transparency in various industries. Blockchain can be used to improve efficiency, reduce costs, prevent fraud, increase privacy, and create new business models. It has the potential to disrupt industries by eliminating intermediaries and reducing transaction fees. Blockchain technology offers several benefits that make it attractive to various industries. The transparency of the blockchain system allows for an open and transparent environment where all participants have equal access to the same information. This ensures that all parties can see and verify the transactional data, and any changes made to the data are visible to everyone on the network. Security is also a key advantage of blockchain technology. The use of cryptographic techniques secures the data and prevents unauthorized access. Every transaction is validated by the network, making it extremely difficult for anyone to manipulate the data without consensus from the rest of the network. Once a transaction is recorded on the blockchain, it becomes immutable, meaning it cannot be altered or deleted. This ensures that the data remains tamper-proof and reliable, which is a critical advantage of blockchain technology. The decentralized nature of blockchain technology also offers cost savings by eliminating intermediaries and streamlining processes. Participants can interact with each other directly, reducing the need for intermediaries and their associated costs. Faster transactions are facilitated by blockchain technology because the need for intermediaries is eliminated and dealings can be processed in real time. The traceability of blockchain technology ensures that a complete record of each transaction is maintained, making it easier to trace the origin of assets or track the movement of goods. Some of the industries that are using blockchain technology include finance. Blockchain is widely used in finance for cryptocurrency transactions, smart contracts, and cross-border payments. Healthcare. Blockchain is being used to store medical records, track the supply chain of drugs, and facilitate secure sharing of patient data. Supply chain management. Blockchain can help track goods from their origin to their destination, improve transparency, and reduce fraud. Real estate. Blockchain is being used to digitize real estate transactions, create smart contracts, and streamline the property buying and selling process. Energy. Blockchain is being used to track energy consumption, facilitate peer-to-peer energy trading, and incentivize the use of renewable energy. Blockchain and distributed ledger technology have been making waves in a wide range of industries, from finance to healthcare. Here are 3 examples of how this technology is being used. Supply chain management. Walmart is using blockchain to track the movement of food products from their source to the store shelves. This has led to increased transparency and efficiency in the supply chain, helping to reduce waste and improve food safety. Financial services. JP Morgan has developed its own blockchain technology called Quorum, which is being used to improve the speed and security of financial transactions. Other banks are also exploring the use of blockchain to reduce fraud and increase efficiency. Healthcare. The healthcare industry is using blockchain to securely store and share patient data. This allows patients to have more control over their own medical records and enables healthcare providers to easily access relevant patient information. It also improves data accuracy and privacy. As these examples demonstrate, blockchain and distributed ledger technology have the potential to transform various industries by increasing efficiency, security, and transparency. Here are 3 websites where you can explore and interact with blockchain. Blockchain Explorer by blockchain.com. This website allows you to explore the Bitcoin blockchain by searching for transactions, addresses, and blocks. You can view the current status of the blockchain, including the number of transactions and the current block height. Etherscan. This website provides an explorer for the Ethereum blockchain, allowing you to search for transactions, addresses, and smart contracts. You can also view real-time data on the Ethereum network, including the current gas prices and mining difficulty. To recap, blockchain is a decentralized digital ledger that uses cryptographic methods to secure data and achieve consensus on the network. The benefits of blockchain technology include transparency, security, immutability, cost savings, faster transactions, and traceability. Blockchain technology has the potential to impact various industries, including finance, healthcare, logistics, and supply chain management. In finance, blockchain technology can enable faster and cheaper cross-border transactions and streamline processes such as trade settlements and clearing. In healthcare, blockchain technology can improve the security and privacy of patient data and streamline the supply chain for medical devices and drugs. In logistics and supply chain management, blockchain technology can increase transparency and traceability, reduce fraud and counterfeiting, and streamline processes such as inventory management and shipping. The potential impact of blockchain technology on various industries makes it important for individuals and organizations to explore this technology further. Lastly, blockchain technology has the potential to restructure the way industries operate and interact with each other. The benefits of transparency, security, and immutability make it an attractive solution for businesses looking to reduce costs and streamline processes. Encouraging further exploration and adoption of blockchain technology can help unlock its full potential and drive transformation across industries. We appreciate your time and interest in our content. We hope you found it informative and engaging. If you have any suggestions or ideas for future videos, feel free to share them in the comments below. If you're a business owner looking to get connected with us, please reach out to us today. We're always happy to collaborate with like-minded people and organizations. Thank you for watching, and don't forget to subscribe to our channel for more exciting content.